cracked it open with this SEM bead, scanning electron microscopy bead, we can see these holes and fenestra in the endothelial lining. Here we can see this Cooper cell, a portion of which has been cracked away, but now it's spanning that sinusoidal space. Kind of like what they do in lymph nodes. Span it so they can filter and digest anything percolating through the liver. Down here we can see this little thin bit of epithelial cell, and this space right here is that perisinusoidal space of this. That's where Ito cells hang out. You crank out the reticular fibers that provide a supporting net-like meshwork for the liver. That relieves my voice. So, Rebecca, same song, 7 words. This is the gallbladder, right? You get this pseudo-villi, right? We're going to call them pseudo-villi, that are full, mucosal full, but clearly you can see there are no goblet cells in that absorptive epithelium. And it has, at least a portion of the cells have a eosinophilic stain because of all the mitochondria that are in the basolateral infold that are pumping sodium out of the cell, pulling water and chloride from the bile, helping to concentrate. Sitting right on the lamina propria, the muscularis, not very well defined, going every which way. What do we have down here? Lymphocytes. It looks like some sort of infiltrate. I can't tell whether it's a full-on follicle, but it's clearly an aggregation of lymphocytes. And you can see they're infiltrating the lamina propria of those folds. And then this up here is just bile that didn't get removed before the tissue was processed. Okay. Every one of you, if not today, very soon should be able to tell me what this is, just from this slide. And you know because? Islets of Langerhans. Right. You can see ducts, right? But that's draining the exocrine portion of this gland. These puppies are endocrine, little spherical aggregations of endocrine cells interspersed throughout the secretory or exocrine secretory acid. Here you can see acidus. You see the actual lumen, which is where the central acidus cell would be. But this is quite different. You've got some capillaries here, so clearly different. And with an antibody to insulin and a secondary antibody linked up to the horseradish peroxidase, you can pick up the staining of beta cells, which are pretty much distributed throughout the islet. Okay, pituitary. We have some very interesting slides that I observed today. All right. This is what I'll call a parasagittal section. Okay. Now, the sagittal plane would be dividing ourselves exactly, completely into two bilaterally symmetric halves. Okay. So if you bandsawed my head, got rid of this half and looked this way, that would be the approach. But it's parasagittal. If it were perfectly sagittal, you'd see the infundibulum coming down here and the tuberales wrapped around it. All right? But we're right off the median plane, so it's parasagittal. But what we do catch quite nicely is the anterior pituitary and the posterior pituitary. So this epithelioid-looking region here would be the pars distalis. When we get to the midline, where we start picking up these colloid-filled cysts, it's the pars tuberalis, and back here is the pars nervosa. All right? Now, imagine that this were a sagittal section, and we had the infundibular stalk coming up here, and right around this region we would have epithelioid tissue, which would be the pars tuberalis wrapped around the front. Okay? Sections that I saw in class were sectioning this way and looking down. Okay? So you saw anterior pituitary, a little posterior pituitary. Might have picked a bit of intermediate, we'll call it cyst, maybe not. Other more interesting sections I saw were like this. So you caught a bit of the anterior pituitary. There appeared to be a separation before you picked up another bit of epithelioid tissue that was wrapped around the infundibular stalk. in some of the stalks there was actually a cavity, which would represent a portion of the third ventricle of the brain. So there you section it like this, and you're looking down. Other sections were sectioned deeper, and you only caught this. So again, this is a classic example where plane of section, and remember that skill of looking at something in 2 dimensions and extrapolating to what the 3-dimensional profile looks like. Good place to practice this. All right. Acidophils, basophils. All right. I don't really care if you can identify this as anterior pituitary. That's good enough for me. I don't care that you can pick out an acidophil or basophil. What I do care about is that you know what types of cells are acidophils, what types of cells are basophils, what hormone each secretes, and what that hormone does. Again, prime candidate for a matching question. I mean, I can see it right now. Actually, it's probably already written. So, high power shot. Here are these colloid-filled cysts. So this is pars intermedia, distalis nervosa. Here, you can see cells that kind of have an eosinophilic, smaller, that one in particular, probably eosinophil. Some of these larger cells, basophils, not worried about it. But note that there's always a capillary network in endocrine glands. There has to be. Otherwise, the hormones can't be distributed. Yes, thank you. Thyroid. So these colloid-filled cysts, not cysts, colloid-filled follicles, okay? Thyroglobulin with iodinated tyrosine, the T4, T3, happening in here. The cells out in the interstitium, the parafollicular C cells. Again, I want you to know where you find them, and if you see a beautiful publication perfect micrograph of one, you know what it is. I'm not going to expect you to find it, but again, what hormone, what does it do? Parathyroid, just a good guess that you've got, I showed you this term the other way in lecture. You've got thyroid tissue here. So you know that there are no ducts here, right? A lot of your, I saw a couple of parathyroid slides that were nice. I think this table had one. And a couple that were totally dog's lunch, all right? If the discriminating characteristics for the parathyroid are clearly no ducts, right? And then clusters or individual oxyphil cells. So that ought to tell you that unless I find a glass slide that has this kind of thing, you're going to see it in a micrograph. Yeah, adrenal gland. All right? You look at it here. First thing that comes to mind, well, 2 things come to mind. One, these medullary vessels. So that gets you thinking, you know, medulla, and then this outer cortical ring here. A lot of your slides, the stain is very faint, right? But you still got these landmarks. And if you apply yourself, you can still pick out the cortex, all right? Again, I expect you to know the zones of the cortex, hormones, and what they do. So here's the capsule. And we've delimited, got these circular clusters. This would have to be the zona glomerulosa, cranking out mineralocorticoids, most important of which is aldosterone. Down here, the zona fasciculata. We're talking about fascicles. Notice how these are cords of cells that will kind of just hang right next to one another. When you get down to the zona reticularis, it's an anastomosing or interconnected mismatch of those cords. So it's a reticular arrangement, all right? And you can pick that out regardless of whether the slide is perfectly stained and the stain is vibrant and new, or whether it's faded, all right? And that's a real test of whether or not you own this knowledge. All right, so next week then it'll be slightly different, and then we'll start the slideshow at 11 o'clock. I want to try to aim to finish by quarter to 10 or 12 so we don't keep going. Have a good weekend.